Okay, so again, good evening sa inyong lahat. So our next topic is all about the arches. So before that, let's discuss first, or let's read first the introduction for a arch. So can you read the introduction, Miss Steffi Gayakan? Eto, nakaano naman. Kahit sa cellphone mo na lang tingnan. Wala. Teka lang ha. Screen recorder pala to. Wait. Kaya namang yan na naman ako sana. Ito pala, sorry. Hindi pala ako na-share screen. Ayan. Sige, basa. Ito. Miss Steffi, ito na. Naka-share screen na ako na. Ah, ah. Wala yata si Miss Steffi. Siya, sige. Si ano na lang. Sige, Miss Lisette Rosales. Okay, so sabi dito sa introduction, yun nga daw ating arch. So ito is a structure kung saan nire-reduce niya yung bending, especially in a long span structure. So kung mapapansin nyo, yung ibang bridge natin, ang design niya is on a shape on an arc. So ang purpose niyan is to resist the bending in a long span structure. And aside from that, di ba yung cables natin, teka, nasan ba yung drawing pen ko? Yung cables kasi natin, guys, di ba kung mapapansin nyo, di ba ang shape niya is an invert U shape. Ano? So ang nangyari lang kay Arch, kabaligtaran lang ni cable. So si Arch, pabaligtad lang na U. Okay? And since yung ano nga natin, yung cables natin, ano nga force ang kanyang ang nag-a-act sa cable, di ba tension siya? So anong nangyari, since kabaligtaran lang din yan, so ang arch, ang force na kine-carry niya is mainly the compressive force. Although, because of its rigidity nga, it should resist also some bending and shearing depending on how it is loaded and shaped. So, hindi lang naman compression, hindi lang daw lagi compression ikine-carry niya. So, sometimes, depende sa loading na nangyari. So, ito is magke-carry din ng shear and moment. So, ayun nga. So, is a compressive force, etc. So, ang ating main concern dito or yung problems na isosolve natin is under the category of a three-hinge arc. So, ang itsura niya is parang ganito. So, paibasa naman ako ng discussion. Mabilis lang to itong meeting natin. Wala pa siguro itong 1 hour. So, Miss Laika Di Mayuga. Paibasa na itong 6.1. Okay, so wag mo muna papatayin. So, ayun nga. So, this is an example of an arc structure. So, when we say three-hinge arc, so parang anong nangyari lang dito, meron kang tatlong hinge dito sa figure na to. So, isa dito kay A, isa dito kay B, and isa dito kay point C. So, shown are the loading. So, dito meron kang P1 concentrated load, and then dito meron kang P2. Okay, so ang ano lang dyan, meron ka ditong point D kung saan hahanapin mo yung force acting at this section. So, as you can see here in the figure, so the support is hindi siya pantay. Ano? Sige, tuloy. Okay, so ang approach kasi dito guys is kung maaalala nyo yung topic natin sa static of rigid bodies, yung pin-connected frames. So parang ganun lang din. Ano? Ang mangyayari lang dito, 'di ba? Ito nga daw yung crown. Ang part pa lang to, itong top na to. This is the crown of the arc. Okay? So ang mangyayari lang, i-disassemble mo lang siya sa dalawang member. So ganito nga yung mangyayari. And 'di ba do sa ating analysis of a frame, of a pin-connected frame. So ayun nga, first thing to do is to assume the direction or analyze the direction of your support. Okay, so once you get the support, so dito sa connection ng crown niya, so i-analyze mo yan. So syempre, if ang CY mo, if ang pagkaka-assume mo sa part na to is yung CY is pababa and yung CX is papunta sa kaliwa, therefore, kapag i-consider mo yung isang part niya o yung kabilang side, so pabaligtad na direction lang yung mangyayari kay CY and CX in order to make it in equilibrium. So, sige, pakituloy naman ang binabasa mo. Okay. Okay, so mamaya mo na ulit. So, ayun nga. So, kung mababasa nyo kasi, base kasi dito, hindi na naalis yung word na equilibrium. Kasi guys, ang mangyayari lang kasi dyan, so ang application or the equation na gagamitin natin is yung parang sa ano lang, na una, kung saan i-analyze natin siya using the equilibrium equation. So, we will apply moment, either of these two support in order to solve for the support reaction. And then once we find the one reaction, we will take summation of forces X and then take summation of forces Y so that we can solve for the other unknowns. And then, since dinisassemble mo siya into two members, o mangyayari lang dyan guys, considering this figure or this side, so kapag nag-moment ka dito, di ba mahahanap mo yung mga unknowns na yan? Or kapag consider mo yung section na to or itong member na to, just take summation of forces X and forces Y to solve for the unknowns. So on this example or this diagram, so meron tayong six unknowns. Ano ito? So we have AX, we have AY, we have BX, we have BY, and so as the forces acting at the crown, which is the CX and the CY. And once we solve all these values, so at any section or at any portion of that arch, masosolve natin yung unknown. So katulad nito, so ang mangyayari lang, if magsasection ka, dapat na perpendicular ka do sa axis or ang pagkakaputol mo is ganyan. Ano? So with that section, ganito dapat yung lalabas na figure sa'yo. Okay? So again, dapat straight cut yan and following the yung pagkaka-curve ng iyong arc. So here of course, the section should be taken, yun nga, perpendicular to the axis of the arc at the point considered. So for example, the free body diagram for the segment AD is shown in 5-9C. So ito nga yan. So considering this, meron kang shearing force and then you have here the normal force, but I think this should have been on the direction of compressive. Kasi nga, lagi naman compressive force yung force natin kay arch. And then you have the moment. Okay? So, the three-hinge arc can also take the form of two-pin connected trusses. So, ito yung two-pin connected trusses. So, meron akong example, yung pangalawang example, each of which would replace the arc ribs AC and CB in figure 5-9A. The analysis of this form follows the same procedure outlined above. And then the following examples numerically illustrate these concepts. So later on, ipapakita ko sa inyo kung paano siya nagsosolve or kung paano tayo nag-a-analyze ng isang arch. So ito, ayun nga, so parang ano lang din siya, yun yung pin-connected frame, pero mag-ano rin tayo ng method of joint. But unlike do sa trusses, medyo iba lang yung magiging approach natin. So susundin nyo lang yung process. So, ganun lang, madali lang din naman to. So before we proceed with the problem, let me just share a video na nakita ko sa YouTube to further discuss about a arc structure. So na-amaze ako nung pinanood ko. So ang ganda pala ng application ni arc in actual or in real life. So again, yung arc nga natin, 'di ba ang tawag dito? I-kinompare siya sa isang cable na kasi yung shape niya, nangyari nga lang pabaligtad. So dito sa video na to, inirelate niya lang siya sa chains, yung kadena. So yung chain na yun, so parang cable na lang din naman siya. So please watch this video. So very informative naman.
In this video, we explore arches and chains. Arches are a popular and beautiful structural component. If you know where to look, you can find them in bridges, buildings, tunnels, wells, dams, and many other places. Chains are also used widely, and they can be found in lifting equipment, playgrounds, and many other settings. As we will show, close parallels exist between arches and hanging chains. And since chains are easier to understand, let's talk about them first. Consider two chains side by side. One is light in weight while the other is heavy. As you can see, the weight of a free hanging chain does not affect its shape, but the spacing of its ends does. Each shape in this family is called a catenary, and each catenary is similar to a parabola. If we add external loads to a lightweight chain, its shape changes considerably. What do you think will happen if we add the same weights to the heavy chain? It turns out that those weights have little effect on the shape of the heavy chain. Chains are often referred to as tension systems because each of their links carries tension. Notice that no bending forces or moments are transferred from one link to the next. If we make a mirror image of a hanging chain, we get an arch. In an arch, the component pieces push against each other, unlike chain links which tend to pull apart. To ancient builders, this represented a huge advantage. If they placed a bunch of stones in just the right positions, they would push against each other and stay in place. This made for structures that were both simple to construct and highly durable. Here is another difference between chains and arches. Because chains are tension systems, they automatically reshape to better carry whatever load is applied. Because arches are compression systems, they do the opposite. So if they are not shaped appropriately for the loads they are asked to carry, they can collapse. As a result, designers must tailor each arch to the loads that it will need to carry. And how did we figure out the shape for the arch? That was easy. We just hung it upside down so that it worked like a chain system, applied the loads, and maintained those angles when we turned it right side up. In the late 1800s, a famous architect by the name of Antoni Gaudi used exactly this technique to design the arches of the famous Basilica of the Sagrada Familia in Barcelona, Spain. To figure out how to shape the arches, he built a precision upside down model of the basilica. His model was like this chain model. It changed shape as he added miniature weights corresponding to the loads of the roof and other features that the arch had to support. The resulting final profile showed him the exact shape to use for each arch. In many real world structures, the weight of the arch is much greater than that of any applied moving loads. In cases like this, the arch shape does not need to take into account the exact position of those loads. This idea is consistent with the heavy chain that did not change shape when small weights were added. Now let's take a look at some common arch designs, starting with the popular semicircular shape. What do you think? Can a thick semicircular arch support its own weight? As you may have guessed, it can. Here is another semicircular arch. It is the same size and shape as the previous one, but its members are thinner. Can this thin semicircular arch support its own weight? You might have guessed that it would collapse, but can you explain why? To make you think even harder, suppose we modify the ends of this thin arch so that they lean further outwards. Can the new shape support its own weight? It can, but are you able to explain this curious result? The mystery of which arches will stand under their own weight and which will not can be resolved with the aid of hanging chains. Remember how arches and chains are mirror images of each other and how chains tell you the right shape to use? Well, suppose you want to evaluate a particular arch design. If you can hang a chain entirely inside the profile of that arch, then it is a shape that can carry its own weight. We call this the chain test. Does this thin semicircular arch pass the chain test? It does not, because it is impossible to position a hanging chain so that it lies entirely inside the profile of the arch, and that is why it collapses. One way to make the arch pass the chain test is to make it thicker. Another solution would be to change the shape of the arch so that it follows the chain shape. For this arch, we could do that by tilting the bottom pieces of the arch outwards. As you can see, when the arch shape follows the chain, it stands up just fine. Suppose instead that we added forces to the chain to make it follow the shape of the semicircular arch. As you can see, outwards forces applied at these points on the chain would do the job. They change the catenary shape into something more like a semicircle. Recall that a chain is a tension system while an arch is a compression system. Thus, we have to reverse those external chain forces when applying them to the arch. When the appropriate forces are applied to the arch, it stands, and if we take them away, it falls. The forces acting on the ends of an arch are also important to its stability, and it is easy to demonstrate this fact. If you prop your head on your hands and place your elbows apart like this, you might be able to feel the forces that are keeping your elbows in place. Those forces have a vertical component, which you can feel as the table pushing up on your elbows. They also have an inwards horizontal component that is carried by friction between your elbows and the table. You'll notice that these forces change depending on the position of your elbows. When your elbows are closer together, the forces become more vertical and their horizontal components become smaller. However, if you move your elbows further apart, you will discover that the horizontal forces increase. In doing these tests, it is important that you not use the muscles in your arm to stop your elbows from moving outwards. If you spread your elbows wide enough, the horizontal forces needed to support your elbows can become greater than the available friction forces, and your model arch collapses. Adding a rubber mat can increase the friction forces available at your elbows and thereby prevent collapse. Arches can take many shapes, from tall and narrow to shallow and wide. And shallow arches like this one can often carry a surprising amount of load if their supports provide sufficient horizontal forces. In the real world, arch supports are often angled so as to better transfer these horizontal forces. Here are a couple of other interesting facts about arches. The horizontal forces that semicircular arches need can be provided by material that fills the space around them. We use blocks for our fill, but in the real world, stones or soil are typically used. In addition, if multiple arches are placed end to end, the horizontal forces at their end can be made to balance, and they can be supported on surprisingly thin columns. Arches can be laid on their sides and used to support large horizontal forces like the water forces that act on the Hoover Dam. As you can see in this top view, even the Hoover Dam has a shape rather like a hanging chain. Oh, and one last point. Not all structures that follow an arch shape actually function as one. In this bridge, for example, the arch shape is strictly decorative. Much more could be said about arches and chains, but here we only have time to introduce the basics. As our team worked on this video, we actually learned quite a bit about arches and chains. We hope that you learned something too. Thanks for watching. We hope you will enjoy some of our other engineering models.
Okay guys, so ayun nga, pinakita doon kung paano ba nagfa-function si Arch. So maganda yung pagka-discuss and illustration nila. Okay, so let's try to solve a problem for an arc. So we have two problems here. So ito lang naman yung way para i-solve siya. So the first thing that we need to do is to determine the support reaction. Okay? So para magawa yun, i-ano muna natin kung pasaan ba yung direction ng ating mga reactions. So here, as shown in the figure, so we have an arc ABC, which is supporting a uniform load of 500 pound per feet. Okay, so yung equation for the arc is given as y is equals to negative 25 over 50 squared x squared. So, naaalala yung sinolve natin, yung previous problem. So, di ba ginamit natin yung general equation for a arc? So, or parabola. Di ba ang general equation niya is y is equals to kx squared. Ngayon, this is negative since yung ating arc is opening downward or papunta siya sa negative y-axis. Kaya negative to. So, application lang ng analytic geometry nga ba. Anyway, so ayan yung sinasabi ng equation na yan. And we are required to solve for the force acting at point D. So, yung actual compression or yung normal force acting at this point D. So again, to solve for that, alamin muna natin yung mga reactions dito sa arch na ito. So ang nangyari lang guys, ito is parang na-isometric lang, para na 3D. Pero sa totoong buhay, naka-level yung pantay yung A and C. Okay? So since vertically load yung isusupport niya and downward yung given na load, so yung reaction mo dito will be directed upward. So let's just name this as our AY and this one as our CY. And then, di ba kung maaalala nyo dun sa video, so paano natin may assume yung direction ng reaction niya? So di ba yung may example doon yung nakahalong baba yung tao? So, syempre, para ma-counteract yung pagbuka niyan, so dapat papaloob yung direction ng ating reactions. Okay? Or this is AX and this one as our CX. Okay? So after this, we can now take moment either of these two support. Okay? But since ang pinapahanap sa atin is yung dito sa point D and yung point D mo is nearer in this support C, so ang gagawin ko, ang hanapin ko na lang value is yung value ng CY. So to solve for CY, we will just take summation of moment, assuming that counterclockwise moment as positive. So take summation of moment at point A, which is equals to 0. So our equation will be Cy multiply by this distance, which is equivalent to 50, 25, 25. So that is 100. And then, so eto, minus na, di ba? So ang gawin ko, i-transpose ko na lang sa kabila. So para maging positive, or that will be 500 multiply by 100. So magiging concentrated load siya. And multiply by the moment arm. Kasi ang mangyayari nga lang dyan is ganito. Ayan. So, di ba ito yung 500 times 100? Okay, so 100, and then this moment arm coming from point A, so that will be equals to 50. So, we will have a value of Cy, sagot. So, 25,000 pounds. Ang gawin na lang natin, guys, since napakalaki ng number na to at mahirap i-type sa ALCU, i-divide na lang natin ng 1,000, or pwede natin sabihin na 25 kips or 25K. Okay, so once meron na tayong value ng inyong reaction, Cy, this time, we will need to solve for the value of your Cx. So, paano natin magagawa yung value ng support reaction mo, Cx, dito sa point na to? So, ang gagawin natin, di ba, ito nga is 3-point, ano yan? 3-point hinge o arc. Ano mas? O 3-hinge arc, kung ibig sabihin nun. So, ang pwede natin gawin, sabi nga, pwede mo siyang hatiin into 2 member. So, ganito yung mangyayari sa kanya. So, ayan, at saka yung kabila. Ano? So, ang gagawin ko na lang, itong left side, yung right side yung ating i-consider. So, drawing ko lang. So, ito yung connection niya. Ayan. And then, ano yung makikita natin? Okay, so, and then, we have here the vertical member. So, ilan yun? Tatlo. 1, 2, and then 3. So again, na-solve na natin yung Cy. So given here is our Cy, which is equals to 25 kips. And then meron tayong dito na Cx, which is hindi pa rin natin alam yung value. At this point B, ayan, so natin nga natin siya. So let's just say, nakalimutan ko pa palang ilagay yung uniform load. So may uniform load pa rin yan. So, ang value niya is 500 pound per feet. And since sa mid-span natin siya pinutol, so the span of this one is 50 feet. Okay? And eto, so the height of that is 25 feet. Okay? So, in order to solve for the value of Cx, so before that pala, i-ano muna natin yung direction ng mga forces dito sa ano natin, sa Bx o dito sa point B. So, yung Bx, pwede natin i-assume in the direction of going to the right. Since yung Cx mo is papunta sa kaliwa, so to counteract that, so papunta siya sa kanan. And since ito is vertical load downward, so let's just say na ang By natin is papunta dyan. Okay? So before that, kailangan nga muna natin kunin yung value ng Cx. So paano natin ma-compute yon? So considering this section or this part of the arc system, we can take summation ng moment at point B. Okay, so assuming that, di nag-iba. Assuming that the clockwise direction moment as positive, so when we take summation ng moment at point B equals to 0, wait lang ha, may nag-Gcash, okay, dumating. So moment at B equals to 0, so we can solve for the value of your Cx. So the equation will be Cx multiplied by the distance of 25. Ano pa ba yung mga forces? And then, yung etong CY natin, so ano ba moment ang maproproduce niya? So counter clockwise. So ang gagawin ko, i-transpose ko sa abila to make it in positive, or that will be 25. Kaso na-akips nga ito, no? So sige, ito na lang i-convert ko mamaya. So 25 multiplied by 50, and then minus, so ano ko muna to, simplify ko muna. So di ba itong 500 pound-feet, pwede ko siyang gawing concentrated load. So mangyayari lang dyan, 500 times 50, ano yung sagot dito? 500 times 50. 25,000. Kaso na-akips nga to, so ang gawin rin natin tong na-akips. So 25,000 pound or 25 kips. Kasi ito na-akips din eh. So that will be 25 and then multiply by the distance. So ito na yung moment arm niya. So itong distance na to is kalahati lang ng 50, or that is 25 feet. So times 25. So we will have an answer for CX, which is equals to pin dot 25 then. Okay. So 25 kips. Okay, so once we have the value of your CX, so by considering this section or this part of the arc structure, so ayan, by taking summation of forces ng X, I could say that yung BX mo is equals lang sa CX, or that is 25 kips. And to solve for BY, so ganun lang din, just take summation ng forces ng Y para mahanap si BY. So, ano ba yan? BY, so equals ko na. So, lahat ng pababa is positive. So, 25 kips. So, minus 25. So, the value of BY will be equals to 0. Okay? So, hindi pa dyan tapos. Ang hinahanap is yung force acting at this section T. Pero i-locate mo natin kung ano ba yung location ni point D. So, first thing that we need to look for is yung displacement niya or yung location niya with respect to the y-axis. So, ano ba yung value yan? Paano mo ba ma-compute yan? So, simple lang. I-substitute mo yung value ng location niya with respect to the x-axis. So, ang sabi niya, coming at this point, di ba, yun nga, sabi nga doon sa inyong parabola. So, para malocate yung ganyang y value, so substitute mo lang dito yung value ng x. So, ang value ng x niya dito, so ano ba ang distance niya? Di ba 25? So, just substitute 25 in this equation, or that will be, so negative 25, again, the negative sign indicates na yung sukat natin is papunta sa baba. Ano? So, negative 25 times 25 squared all over 50 squared. So, what is the value of this distance? So, let's just say that this is y. So, what is the value of that y? 6.5. So, negative 6.25. Or just take the absolute value of that. So, that is 6.25, which is downward. 6.25. Ayan. So, ito nga yung distance niya. And, if magsasection ka dito, di ba dapat daw yung putol mo is perpendicular, or kapag in-enlarge natin, so i-drawing ko lang ulit siya, isasection ko na siya dito, ha? Ang mangyayari, puputulin na natin siya. So, para magawa yun, section ka lang dito. So, palitan ko lang yung kulay nito. So, puputulin ko lang siya dito. Ayan. So, kapag minaximize mo siya or in-enlarge, ganito yung makikita natin sa kanya. So, dito na lang. Ayan. So, again, this is point B. So, nung pinutol natin, hirap talaga mag-drawing. Palitan ko yung marker ko, yung mas manipis. Lapit ko ng konti. So, again, this is our point B. Ayan. So, nung pinutol nga natin, again, dapat ayan. So, dapat perpendicular yung pagkakakat natin. So, ituloy ko lang to. Again, so saan nga yung ating putol na yon? So doon sa point D, no? So ang makikita na lang natin is ito. Ayan. So ayan, and ayan. Okay. So yung selection natin siya, so ang matitirang force na lang sa kanya or yung force is are the following. So ito, meron ka nga ditong normal force o yung compressive force na hinahanap natin. So let's just denote that as your ND. And then aside from that, we have here a shearing force. So that is our shearing force D, and we have a moment. So that is our moment D. Okay? So aside from that, ang natitira pa nating forces ay ang mga sumusunod. So meron ka agad dito na uniform load. So ngayon, ang span na lang niya is ito. So yung horizontal distance niya, so nasa nga si point D, so that is at 25 feet. So it is 25. Again, yung Y natin, na-compute naman natin kanina. So ito daw ay 6.25. And yung mga na-solve nating force, so di ba meron ka ditong BX, which has a value of 25 kips. And yung BY mo, so that is equals to 0. Tama? Okay, so ang kailangan pa pala nating malaman dito guys is yung kanyang degree of inclination. Kasi ito, ano bang pala ito? So kailangan kasi nating mahanap to. So with respect do sa horizontal line, kailangan nating mahanap itong theta na ito. Okay? And at the same time, if that is theta, so itong with respect do sa shearing force, ayan, sa may mambura. Extend ko lang ng kaunti pa ito. So itong shearing force na to, ayan, that will also make an angle of theta with respect dun sa y-axis. Pero paano ba natin ma-compute yung tetang yan? So para ma-compute yung tetang yan, again, balik tayo dun sa equation ng inyong parabola. Okay? So we all know that yung inyong theta can be computed using the tangent. Okay? So again, alam natin na yung tangent theta natin. So that is the difference between the y all over dx or the dy all over dx. So ang kailangan natin is to solve this equation in terms of dy of dx. So ang mangyayari lang dyan, we need to take the first derivative of this equation. Or, this equation can become, so take the first derivative, di ba? Ito is magiging dy lang, itong y na to. That is equals lang sa, ito is equals lang din sa slope ha. Ayun. So, negative 25. So, ito is a times b, di ba? So, ang mangyayari lang dyan, let's copy the first term. 25 all over 50 squared. And then, ito, take the derivative of x squared. So, yan ay magiging, ano? Di ba siya ay magiging 2x lang? Tama? So, 2x and plus x squared and then derivative nito, so which is equals to 0. Okay? So, ang ano niya, limits niya is from, again, 0 up to the distance of 25. So, just substitute the value of 25 here. So, ibaba ko na dito si dx ha. Kasi ito may 2x dx pa dapat. Ililipat ko na lang dito para mahabol natin yung form ng equation na yun. So, just substitute 25 here in this equation. Or that is negative 25. So, multiply by 2 times 25 all over 50 squared. So, what will be the answer for dy over dx? So, ang na-answer niya is negative. So, the negative sign again indicates na ito is opening downward or pababa yung buka. Ano sagot dito? Negative 25 times 2 times 25 over 50 squared. 0.5. Okay. So since may value na tayo ng 0.5, so substitute nyo lang dito. Sorry. So that is negative 0.5. So the theta is just equals to the arctangent of 0.5, of negative 0.5. So what is the answer? Negative 26 point, hindi negative kapag negative 0.5. Char. 26.5651. Okay. So ayan, so kompleto na tayo. So we can now solve for the value of your NB. So paano ba natin siya kukunin? So ano lang din, just use the equilibrium equation. So for this, ang gawin na lang natin para mas madali, hindi na natin gamitin yung MT. Mag-summation na lang tayo ng forces X and forces Y. So let's start first with summation of forces X. So assuming to the right forces as positive, take summation of forces X equals to 0. So ang gagawin natin, unahin natin si ND. So yung ND mo, multiply by, paano mauha yung X component niya? So di ba cosine? Cosine of theta. So ano nga yung theta natin? So 26.5651. So multiply by 26.5651. And then, pasaan ba ang horizontal force nitong si shear? So papunta rin sa kanan. Sa kaliwa. Tama. So plus, the shearing force D. And then, para makuha siya, since ito yung theta mo, so sine. So sine of 26.5651. So meron pa ba tayong horizontal force? Itong 25 kips. Tama? So kung papunta siya doon sa kaliwa, i-transpose natin sa kabilang side ng equation. So this will be positive. 25 kips. Okay, so let this be your equation 1. Yan. So this will be our equation 1. And the equation 2 will be coming from the summation of forces, Y. So again, this is 500 pound per feet. So ang gawin ko na lang ulit, since na-akips yung iba nating unit, so i-solve na natin siya in terms of kips. So 500. So again, this is can be converted into a concentrated force. Hirap talaga nito. So maging mangyayari lang dyan, 500 multiply by, so ano nga yung span natin na to? 25. And then i-divide na natin ng 1,000 para ang sagot niya dito is kips. So ilan to? So 12.5 kips. And then yung distance niya patungo dito, so that is 25 over 2. Pero hindi naman pala natin kailangan. Anyway, so balik tayo dito. So the next equation will be coming from summation of forces Y. So just take summation of forces Y, assuming that upward forces as positive equals to 0. So let's start first with the ND. So ang ND mo, so ND multiply by sine of 26.5651. And then itong shear D, so ang Y component niya is papunta sa baba. So therefore minus shear D sine, shear D. So ito nga galing sa Y axis, so cosine of 26.5651. And since ito, pababa nga lang din, so i-ano na natin dito. So equals to 12.5 kips. So this will be our equation number 2. So to equation 2 unknown, we can solve for the normal force D and the moment shear D. So what is the value of ND? What is the value of your shear D? So paipindot na lang sa ALQ. So 27.9508. So parang iisa lang yung naririnig kong pumipindot. Parang iisa lang yung estudyante ko dito. And then yung shear D, 2.3817 times 10. So, negative 5. So, kung mapapansin nyo dito, guys, this is very small value. So, parang nangyari dyan, 0.12342. So, we can say that this is almost equals to 0 kips. So, wala na yung shearing force. So, maybe because of the rounding off, kaya nagkaroon tayo ng counting value ganito. Okay, so, ito yung final answer natin for this problem. Ito lang naman yung hinahanap sa kanya. So, napatunayan natin na shearing, compressive force talaga yung i-carry ng doon sa point na yan. Doon sa point B. Okay, screen capture. Okay, so next problem tayo. Ayan. So, paibasa naman ako ng next problem natin. Miss Abigail Aguilar, please read the problem. Okay, so yung may dash line ka daw dito. Ito, this actually kasama rin dapat si HG. So yung dash line dyan indicates that yung member na GF mo and HG would not carry any force. Okay? So, ang pinapahanap dito is yung ating forces in members CH and CB. So, dito yung pinapahanap. Itong member na to and this one. So guys itong AE, ito yung pinagkamalian ko kanina. Akala ko kasi kanina shadow to. Ito pala member din. And if you're going to zoom, medyo ano lang kasi, blurred na. Ito is a pin connection. And then ito, kung mapansin nyo, pabilog siya. So this is a roller. Okay? So, ano nga yung una natin kailangan gawin? So, we need to solve first or to look for the value of your reaction. So, to solve for the reaction, ano muna natin, tawag dito? Assume muna natin yung direction ng mga reaction niya kay RA and RE. So, again, this is upward force. So, let's name this as our AY. And yung AX natin, so, paganyan. And yung EY, so, gawin natin na pataas na ganyan. Okay, so, to solve for, tawag dito. So, to solve for the reaction, so it's either mag-take ka ng moment dito kay A or take ka ng moment dito kay point E. So, ang gawin na lang natin, just take summation ng moment at point A. So, to solve for your EY. So, by taking summation ng moment at A, so the equation will be EY. So, medyo kabisado nyo naman to pagkuha ng reaction. So, EY times 12. So, bilisan na lang natin. Is equals to 15. Unahin natin yung unang 15. So, multiply by 3. And then plus 20. Multiply by 6. And then plus 15. Multiply by 9. So, the value of your EY will be equals to what? 25 kilonewton. Okay, so ano pala no, symmetrical yung loading natin. So, ang pwede pala, pag samasamahin mo lang itong tatlo, and then paghahatian na lang itong dalawang Y. So, kapag nag-summation ka ng forces ng Y, di ba, yung AY mo will be just equals to the EY. And then equals lang siya sa 25 kilonewton. And yung AX mo, eto, so since wala ka namang horizontal loading, therefore yung kapag nag-summation ng forces ng X, considering the whole figure, so that will be equals to 0. Okay, so kagaya nga ng ginawa natin kanina, since this is a 3 hinge arc, so ang gagawin natin, hahatiin ulit natin siya into 2. So, habang idinodrawing ko yung figure, sige, mag-ano muna kayo dyan. Drawing ko lang ulit itong structure na to sa bandang baba. Wala. Ay, putrek. Ah. Nakapag-semis na kayo sa ibang subject. Last week. Ako na lang yung hindi pa. Saang subject? Wow. Ingat kayo, baka malunod kayo. Lunod na ga. Okay lang yan. Kami nga dati, nilunod na sa tubig, binaon pa sa lupa. Kasabay kasi nun yung aming, kasabay kasi namin yung time nung ano, yung soil mechanics, geology nyo ngayon. Okay. So, ayun nga. So, ito, this is the best I can do for this figure. So, ilatag lang natin yung mga forces. So, this is, ayan. So, guys, ano to ha, malito lang ba't naging ganun o ba't naging ganyan yung figure. So, magkaiba to sa method of joint sa truss ha. So, sabi ko nga, ito is parang frame, ano lang, yung pin-connected frame. So, ano pa bang kulang ko? So, ang mga distances na yan, so dito ko na lang isulat sa kabila. So, this is 1 meter, 1 meter, and then, alas 8 na, dismiss. And then this one is 4 meter. Okay, so yung horizontal distance niya dito, so this is 3. This is also equals to 3. Okay, so ibaba ko lang ng konti. So yung AY, na-compute na natin kanina. So ang value niya is equivalent sa 25 kilonewton. So AY is equals to 25 kilonewton. And for this, di ba ito nga yung ating crown, yung point C. So mag-assume tayo ng direction ng magiging ano niya, forces in that member. So since vertical yung load niya is pababa, so ito, the reaction here would be, or the force, internal force carrying by the point C is upward. And then yung ating CX, so gawin natin siya na paloob. Okay? Kasi dito sa baba, ito yung pinagkamalian ko kanina doon sa nauna. Nakalimutan ko nga na ito is a member lang din. So normally naman, yung mga bottom chord natin sa truss is on a tensile force. So let's just say na paganito siya. Okay? So again, the negative sign naman will tell you if mali or tama yung pagkaka-assume mo. So kanina kasi kin-assume ko siya in compression. Nagkabaliktad dito kanina. So diretso na lang natin na tama yung assume. Okay, so ang una natin gawin is to solve for the force in member AE. So ang gagawin natin, just take summation ng moment dito sa point C. So assuming that counterclockwise moment as positive, take summation ng moment C equals to 0. So the force in member AE multiply by the distance of, so ano yung distance niya? So that is 5. So ano pa ba ang force? So pag ganito, ito, pa-clockwise din. So equals na natin. So 25. So clockwise, so positive siya kapag nasa kabila. 25 times 6. And then yung 15, so minus 15 multiplied by the distance of 3. So the force in member AE is equals to pindot sa 21 kilonewton. Okay. So since meron na tayong force member na yan, so again, considering this uh, part of the arc structure, so mag-summation lang tayo ng forces X para mahanap natin yung CX. So by taking summation of forces ng X, we can say that yung CX mo is equals lang sa force in member AE, which is equals to 21 kilonewton. And kapag nag-summation tayo ng forces ng Y, assuming upward direction is positive, we will solve the value for CY. So that is equals lang sa pataas. So 15 plus 20, itong mga loads na to, and then minus 25. So what will be the value of your CY? So that is 10 kilonewton. Okay? So 10 kilonewton. Okay, so since may mga forces na tayo sa member na yan, pwede na tayo mag-proceed by method of joint. So, ang method of joint dito, ang i-consider lang natin figure is hindi itong kabuuan. Ito lang part na to. Okay? So, unahin natin yung point G. So, lagyan ko lang dito ng label. So, this is point G and this is point... Ano ba yun? Sorry. This is C. C. This is our H and this is our B. So, again, ito nga yung pinapahanap sa problem. So, unahin natin dito sa point G para mahanap natin tong GC. Okay? So, hindi natin kasi masosolve yan. Itong kapag dumiretso tayo dito sa point C kasi merong tatlong member na ano. So, kailangan muna natin mahanap si GC. But by inspection, we can say that yung GC mo, saan ba yan? So, by inspection, di ba yung GC mo is equals lang sa, kapag nag-take ka ng summation ng forces vertical, equals to 0, at joint G, I could say that GC is equals lang saan? Equals lang siya sa 20 kilonewton. So, ang direction ng GC mo, dito sa point G, so compression siya. So, kapag kinonsider mo yung joint C, ayan. So, drawing na natin yung joint C. So, di ba dito pataas yung GC mo? So, kung pataas dyan, dito, magiging pababa. Kasi compression nga siya. So, GC. So, this is compression. Okay, so pababa yan. And then, ano pa yung mga force na nag-act do sa C? So, di ba meron tayong CY na pataas? So, ang CY mo, again, ang value niya kanina is 10 kilonewton. And then, we have CX, which has a value of 21 kilonewton. And then, yung dalawang member. So, again, kayo na lang bahala kung paano nyo gustong i-assume. Pero para hindi na diretsyo na tayo, alin nga dito ang tension. So, ito yung tension. And then, ito yung compression. So, let's name this as our force in member CB. And then, this one as force in member CH. So, ano yung slope niya? So, 1. Okay, so pareho lang. So, 1, 3 square root of 10. And then, itong baba. So, ganun lang din. 1, 3 square root of 10. So, yun lang. To equation 2 unknown. So, unahin natin to CH. So, by taking summation of forces ng X, assuming to the left forces as positive, equals to 0. So, the equation will be, so FCH multiplied by 3 over square root of 10. And then minus yung FCB multiplied by 3 over square root of 10. And then, so kung dito is papakaliwa ito, so equals to negative 21 kilonewton. Okay, so this will be our equation 1. And yung equation 2 will be coming from summation of forces ng Y. Or vertical. So FCH, and then multiply by 1 over square root of 10. And then ito, yung CB, so parehong pataas, so plus FCB times 1 over square root of 10. And then equals, so ano nga yung GC natin? So equals, so pababa, so 20 yung GC, and then minus 10. So this will be our equation number 2. Okay, so solving simultaneously equation 1 and equation 2, we will have a value of your FCH and your FCB. So don't forget, ito ay naka-negative ba? Baka magkamali lang sa pindot. Sige, what is the answer? 4.7 7434 kilonewton. So, ano nga yung CH natin? So, tama na siya ay tension. And then, yung isa, CB, sabay-sabay, 26.987 87494 kilonewton. 8, 8794. Ayan na. So, this is in compression. So, ayan. So, ganyan lang po yung pagsasolve ng arc. So, madali lang, ano. So, mag-upload na lang ako guys ng practice problem. So, ano na, sige, pagpahingahin ko na kayo. Hindi nyo na kailangan gumawa ng plates para doon sa natitirang mga topic hanggang next week. So, ano na lang, try nyo lang isolve kasi lumabas sa exam. Pagpraktisan nyo na lang. So, kagaya ng ginawa ko kanina, tatanungin ko na lang kayo kasi nga sa Sabado, di ba, semis natin. So, ang coverage niya is influence line. Influence line lang dapat. Pero nasa sa inyo kung gusto nyong isama itong topic na cables and arches. Yung kabila, sabi daw, isama daw kasi madali nga lang daw itong cables and arches para daw at least sure na makaka-score sila. So sa tingin nyo, isasama natin, influence line lang tayo or isama natin tong cables and arches? Sige, kung nahihiyang sumagot, type nyo doon sa comment section, sa chat box. So, influence line lang ba tayo? Influence line for a truss and a beam? Influence line lang or kasama si cable and arches? Sige, nahihirapan pa yatang mag-decide. Hindi pa yata nagmahapunan yung iba. So, ay ano nyo na lang kay Josa kung ano yung mapag-usapan niya. Ano? I-message nyo lang kay Josa. Sige, thank you. So, tomorrow, we will start a new topic. So, start na tayo ng deflection. Okay? Isama po ni Lord. Anong isama po ni Lord? Sige, kumain na kayo. Nalipasan na ata kayo ng gutom. Dasal na lang. Sige na. Good luck sa exam niyo bukas sa Hydro. Galingan niyo. Offer naman daw sa second sem. Hindi, joke lang. Hindi, biro lang. Kaya niyo yan. Sige na.